Hey everybody, this is Larry. This is day 3 of the December Legal Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's farm. Why was that loading? My computer should be, my internet should be pretty fast. Anyway, maybe my computer. But why do I have to keep on logging in every day? Do they keep on logging me out? Oh no, something is going really weird with Leetcode, or maybe just me, I don't know. But today we have 3625, count number of Trapezoids 2. So okay, I assume more difficult version of yesterday's problem. Let's take a look. Okay, so number of unique trapezoids that any 4 distinct points. Okay, so at least one pair of parallel sides, not just axis parallel. Okay. Yeah, I mean, the first thing I wanted to see was whether well, just what the constraints were, right? Because yeah, because yesterday's was what, like 10 to the 5th or something, which is not n squareable. But given that n is 500, then maybe we could do n square stuff, right? And what does that mean by n square? Well, n square means that every pair of points now have a slope, right? You have to do some weird things about vertical lines because slope is infinity, right? But otherwise, every 2 points, every 2 points form a slope, and then now, in a way, that slope, you can now reduce that to yesterday's problem, right? Is what I'm trying to say in a really bad way. And what I mean by that is that, like, if 2 things have the same slope, you could just run yesterday's algorithm on it, right? Give me a second, actually. I forgot to plug in, and now I have I have a decent amount of battery, but I just want to also not forget. But okay, right? And because we have an n squared number of distinct slopes in the worst case, you can imagine like a point in the middle, or just like points in a circle, really, right? Or I mean, I know, or like 500 point agon or whatever. Then you have slopes of n squared slope, so there's something like that. So for every n squared slope, we could do an O of n algorithm, and that'll be n cubed, right? So that might be too slow. Wait, is it n squared? No, yeah, for every n squared slope, for every n squared slope, we do the O of n algorithm, then it'll be n cubed, and that would be too slow, right? I want to make the argument that a lot of those are not possible, because that's the absolute worst case, but there's like some balancing there, right? And what I mean by that is that if the n square distinct slope, then you can imagine that each of them is just O of 1, right? Because you only have one set of points or something. Where the other case of, okay, well, if you have O of n, because all of them have the same slope, then you don't have n squares different slope. You just have one slope. So then that's O of n, right? So in theory, that suggests that it'll be the algorithm is like between O of n and n square, and not actually n cubed. And I think that's enough for me to YOLO try. Yeah. And if you want, you can kind of go back to yesterday's problem. I definitely recommend, if you didn't understand yesterday's problem, then you definitely should, watch the video or ask questions in a informative way and so forth. But that's basically, right? So yeah, so now we just have to kind of, what's it called? Retool what we did yesterday with this, right? So yesterday, I mean, we can even look at it, right? So I have all this stuff, right? So yeah, so then now we can do maybe something like for x1, y1 in points for how do I usually write this? Maybe this is a dumb way of writing it. Maybe I'll just write it this way so that it's more precise, right? And then now slope is equal to, maybe we can write like x1, y1 is equal to points of I x2 y2 is equal to point sub j, and then now slope is equal to x2 minus x1 over, or I think technically it's the other way around, but I mean, it doesn't really matter as long as it's consistent, right? Because there's, you lost generality here, right? So you can convince this is a slope, but of course this could be 0, so we can actually maybe just use it as a fraction in a weird way, right? Because if this is 0, then this is infinity, obviously, right? If this is 0, that's fine, I suppose. So then now, but you can maybe just say delta y, delta x is a thing, but of course then now you have to normalize it because, like 3 over 6 is not equal to 1/2 if you don't reduce it, right? Or, you have to do maths about it. There are other things you can do about it, but, right? So maybe we can just write dy is equal to y2 minus y1, right? Dx is equal to x2 minus x1, right? And then maybe GCD is equal to, or G for GCD is equal to GCD of absolute dy, absolute dx, right? And maybe we just do some like weird math on, or not weird math, but I forget what happens when you do GCD of 0, actually. GCD of 0 and 10. That's not 10, but it's the same idea. Does that give me, what does that give me? Just 100, right? So that's kind of weird, maybe. So we have to be careful about stuff like that, right? Because I always forget the behavior for these. I don't even know if it's undefined, honestly, because sometimes some of these are undefined, but with a consistent thing that, I don't know, that you shouldn't exploit anyway. But I actually don't remember for this case until, that's why I had to check it. Okay, right? So then now maybe like if absolute dx is equal to 0, so then maybe slope is equal to none for now. If dx is 0, then this is vertical, right? So then maybe slope is equal to, I don't know, 1, 0 or something, right? And that's fine because we're using, so maybe I'm not being too clear, but I'm using the slope as a key, right? So as long as you're good about it, this is fine, right? This is easier, but I might as well condition this. And otherwise then slope is equal to, I want to say dy over g, dx over g, but it's not quite this either. And the reason is because of negatives, right? Because, yeah, there's just a lot of things that can happen with negatives. So let's actually check for that first, right? So basically, if dx is less than 0, then we just converted it, right? So then now dy dx right? And I think that should be fine with the normalizing, and now we can GCD it, because then now if there's a negative, it'll be on the front and on the top on the dy, and as long as you're consistent with these keys, then that should be okay. And then now that we found the slope, then we can just do the math that we did last time, right? Here you can assume that the idea that we did yesterday was just that the slope is 0 or whatever. Yeah, 0 for a vertical line. So then now we just kind of do it this way, where maybe we just have the same thing. No, I mean, no, not quite that. It'll be default dictionary, right? Where each key would map to a collections.counter, right? So then now this is the same thing. We do ys of slope of, in this case, wait. Well, in this case, then now, okay, so you have a slope, so you have to figure out the y-intercept, right? Yeah, I mean, or the x-intercept, whichever one is. It doesn't matter as you consistent. So then now it's just, this part is a little bit annoying then. I thought I could just do it this way. But yeah, then now the slope, and then maybe we just use dy, we add by 1, right? Well, because you have ax plus y, you assume the the formula for line is, what is it? y is equal to ax plus b or something, right? And then if you just want to say a is equal to 0, to find the, oh sorry, x is equal to 0 to find the y-intercept, then this, yeah, the dy would be that, right? I'm being a little bit lazy about this, but yeah. But we have to also. I thought I could just squeeze it in, but maybe not. Apparently, we can do something like this. If dx is equal to 0, dy is. If dx is equal to 0, then it's just all the height, right? So dy, yeah. No, dy is 1. Wait, what? If dx is equal to 0, then we just care about. Wait, if dx is equal to 0, that means both the x's are the same, so we just use one of them. Right? Am I getting this right? Maybe I'm just doing this wrong, honestly. But same idea here. Yeah, I think that makes sense. And this is, of course, the same idea as we have here, right? We just kind of throw it out for both vertical lines, horizontal lines, and then just for general slopes, right? Yeah. And then you have to do this combinatorial thing, which you actually can roll this into here if you want. But we'll just kind of do later, right? Because then now we can say for slope in ys.keys, and then now for in this case, because slope is just what all the things, and now we do the equivalent of this first maybe, and then just kind of copy and paste here, right? Where pairs is equal to 0. For I call it y, but it's not really y, I guess. Oops. But yeah, today I'm a little bit, like on my explanation, I'm using a little bit of shortcut and referring to yesterday's video, because I mean, it was just yesterday. So please watch that if you're not following through some part of this. But basically, we're just generalizing the slope part of it. Okay, and then now we say, yeah. So this is the total, right? So total, and then we choose 2 of these. Right. There's no mod on this one, huh? Yeah, so which is the same with this idea. Though I guess alright, to do the same thing I did last time, I guess I'll write it here like this, right? And now we do another loop, right? And yeah, we have to do n is equal to 0, I suppose. But yeah, and then we just do another loop, which is the same idea, right? As yesterday's, in which we just take the current pair and then we add it out and then subtract it out, right? So in fact, why not? Why not just copy and paste, right? And make minor adjustments. The only thing that I have to adjust is this to slope, I think, I hope. And then that's it. I don't think there's mod on this one because points is 500, so the numbers are much smaller. So that should be the idea. Hopefully this is right. It is not. Do I just always return 0? I do always only return 0. Why is that? Dong dong dong. Alright, well, I think the idea should be accurate, but let me see. Well, I don't know how to read this. I have too many counters inside this. Oh, okay. This is the slope. I see. So negative 1, 3. Oh, I see. Also, well, I mean, it's not the only thing, but I don't know how I messed this up and use division like that. That's pretty bad. Okay. 1, 2, 3. So we have -2, 1, okay. 1, 0, 1. Did I mess something up? Okay, so this one has, oh, it's one, it's not just one. Let me think about this for a second. Because the thing is that I'm using one, but that part is actually incorrect. The reason why it's incorrect is that this should be a pair of stuff, right? No, it's number of point, or rather, how would I say this? How do I count this? Because basically this is saying that, well, there are 2 points, and on the slope, you know, so we have to kind of increment for both, but we also don't want to double count, right? So maybe we have to use a set in some way, right? So maybe that's the better way. Because then now we do like maybe something like this. And now instead of counter, we use a set, right? Yeah, you can actually do something like this instead. But and the reason is because for that slope, for this intercept, we want to kind of we want to make sure that they exist. And I guess for consistency, should just go to x2, right? And then now this part is a little bit annoying too, right? Yeah, but this now changes into the length instead. We still have to fix that though. I haven't forgotten it, I just have to think about it. Okay, so this is the slope. And then now, yeah, maybe just same thing actually. So is that right? Did I mess this up? Collection default. No. It's yeah, something like this instead. Okay, I mean we're overcounting, which is different, but maybe not that bad. Part 1 was right. Part 2, I get 2 instead of 1. Why do I get? I mean, this. Why do I get 2 even? Do I double count because I have the slope and the inverse slope? Let's see, right? So 0, 1, that's dy dx. I see. We're double counting because wait, is it? No, this should be fine. This is fine. We only have 2 points. This is fine. This is fine. Am I doing? So there's only one of these, so that should only be. Let's see. So on 0, the 0, 1, that doesn't really make sense, honestly. Do I do anything weird? GCD, no. So 0, 1, so we have this. Y1, X1, Y2, X2, right? So that's, oh, I was looking at this graph wrong because the boxes are half boxes. Meaning that 1 is actually the middle point and 2 is, okay. So I just misread this because I was like, I don't get how, okay. Okay, so this makes 1 box, so why are we getting 2? Do I double count? I do double count because I multiply. Did I not take a double? Oh yeah, I forgot that I do deal with the double counting here. So then, okay. So we can, but then how would I get the first one correct? Is it by luck? And or wrong answer? I don't know. I feel like it should always, do I always double count? I feel like we should always double count. But then now, you know, obviously the first one's wrong, which is fine maybe. But we'll just see. Do slope. What is that slope? That is a 1-1 slope. Maybe a negative 1-1 actually. What's this? That doesn't give me anything, I don't think. Yeah. But it should give me 1. Yeah, so the intercept is really wrong. Maybe that's not how I do the math. I was just kind of lazy here, to be honest. Okay, I mean for the vertical and the horizontal makes sense. What am I doing about the slope? We want to group them by the y-intercept. So it doesn't really make sense that like maybe the x1 part makes sense, but the y1 is not the intercept then, right? If we make x1 0 to make y1 the thing, then why would you do x1? Okay. I think this part, my math is just bad, so give me a second. But I think this is figure out, bro. I think this is just, I kind of YOLO lazy on this one. Because this thing is counted, or this thing more specifically, which is the vertical line, and it seems like that's correct. But the actual things are not for the other one. So okay, so for this one, we have 2 points. The y-intercept should be -1, right? So, but we do y1 and y2, so they don't even merge at the same place, so that doesn't even make sense. So what is the y-intercept? Something is off here. Ax plus b. Okay, I just have to do the math. I think I was just trying to do it in my head too long. I don't have paper, right? So okay, so we have a formula: y is equal to mx plus b, right? We know what the slope is. Then we have to solve for b, is it? Right, because we know x, we know y, so then we have y1 is equal to m, or slope, times x1 plus b. We solve for b, so y1 minus slope times x1 is equal to b, right? So okay, so let's just write that. Well, slope is a thing, but okay, fine. Okay, slope is a fraction, so I'm trying to think whether I can, oh no, it's, oh, but it's x1 times slope, so that's fine because x1 now, because slope is equal, okay, let's write it out, is equal to dy over g divided by dx over g times x1, right? And then now, of course, just for simplicity, we could multiply g to make the fraction a little easier. So then that's it, right? So you have this is the b, and then b would give is the y-intercept, because then we set x is 0 to 0, right? Yeah, let's do it this way for now. And then now b, now you add on the y-intercept, right? So this is the y-intercept. I think this can be a count. I don't know. I think this doesn't actually have to be. I think now this is correct, and this could be a count, right? But we're gonna add the x's. It doesn't really matter, I think. Okay. I mean, I don't know. Am I confident about this? Honestly, not really. This is kind of a fraction e thing. Maybe we can do this just to make it slightly, I don't know, more stable. I don't even know if that's true, but we're YOLO submitting it anyway. Okay. I mean, the idea, I think, is probably roughly right, but there might be some like weird case that, or like my math is a little bit off with fractions or something. I mean, yeah, the analysis is kind of tricky. But yes, because when you have like all these things, then it's like, well, does it really merge on this, right? What is going on though? So that's the y-intercept. Why am I getting the? I'm doing an extra one, which is not right. And this is kind of annoying too, because I don't know how to really look at this. Or how to debug it more precisely, because I don't know which one is wrong, right? We can write some, we'll just write it out real quick. Slope, ys slope. At least I'll add more n lines to it. So okay, so this one we have 5 points. I mean, this is horizontal, so 5 choose 2 times or whatever, right? So maybe we just put it here. Right, so that's already 10 from those, and then that's it. But I guess that probably sounds, if yeah, that means that this is yesterday's problem basically, maybe, but I put 11, so that means that I added an extra one, and there's this one. Dun dun dun. Did I miss something weird? That sounds reasonable conceptually. Are the x's wrong? I don't know. I mean, my guess would be that this is wrong, but I don't know how it is wrong per se. Yeah. What's the slope? 50, and then this is the y-intercept, which is fine, maybe. Yeah, okay, fine. Okay. So we do this first, right? So it thinks that this is 0.1. Okay, let's take a look. I mean, maybe that I'm wrong on the other one. Right, dxdy, is that true? This is 66 is probably true. And 100, okay. Negative 75. Did I get it wrong? Did I do something wrong? Y1, y2, y1. So negative 9 minus this is 66. 11 minus 89 is minus negative. Okay. I mean, this seems like this would be right. Wait. No, yeah, this seems like it would be right. Oh, it double counts, doesn't it? Because this is vertical. So it's a parallelogram, so it double counts. Huh. I did not expect that case. Okay, I see. Wow. How do I handle a parallelogram? Because now it has two things that does it, right? Okay. Huh. Now I have to step back a little bit. I mean, I think I'm 95% of the way there, but it may be that the last 5% is really hard. I'm not gonna lie, right? But we have to try to figure out how to get rid of the double counting, right? I guess we can, I mean, there are two ways to do it. One way is just try to figure out how to incorporate it here, which I was trying to think about it. But then maybe we can also just count the number of parallelograms and then subtract them out, right? Because it's of the duplicates. How do I find parallelograms? Jeez. Without like n to the fourth, obviously. Let's see. Well, n cubed would do it, right? N square. Yeah. Well. Wow, this is harder than I expected. Okay. I mean, n squared should do it, but wait, is that true? Can I remove it? I'm thinking like, okay, so we have, we have 1 point, 1 point, and now you have here, right? So that means that all the other ones, you just basically like flip on this, and then count the number of parallelograms. I did not expect to. Right. So for every 2 points, can we count the number of parallelograms in quick time? I don't know. Huh. That's hard. Maybe I have to think of the other way of just not double counting. Because basically the reason why this is failing is because I think we have something like this. And it's just lucky that I noticed it. Pretend it's a pretend the lines are parallel. I'm drawing with my fingers, but then how do you handle it? How? Huh? Not gonna lie, I did not. I did miss this edge case, and now I'm trying to think. I mean, we can definitely map out the pairs of equal numbers, right? Because basically the idea about this parallelogram is that okay, so let's go back. Let's just use a very straightforward or the same one as yesterday's, right? The idea behind yesterday's. So you have oops, you have basically two lines, right? And then you have points on those two lines, right? You have points. Why did it? I just changed the color. Did I not? You have points on those two lines, right? And our logic was that you can choose any two, and that's fine because it would just create, or any two from the top, and then any two from the bottom, and that'll be okay, right? But now I guess we are. But how do we do that without constructing? Maybe that's fine. Maybe it is fine. Do I use this x1, x2? Because to intercept is fine, and then now x1, x2, right? Because maybe in here, instead of just storing x1, x2, we store the line lengths, right? And then now basically it's saying that this is so annoying. I just want to go sleep. Okay, fine. I mean, I think I got it, but it's still like just very annoying to actually implement. But the idea here is that, okay, I put x1, x2 because here, well, here we just do the points, and the reason why we did the points is just because it's similar to what we have here, right? But actually, maybe we just, instead of doing this way, we I don't know if I have to handle this differently. That's why I'm thinking about it for a second. This is the intercept. Am I doing this part right? It's y1 and y2. Dx is equal to dy, Larry. So this is the same. So instead of doing this, we can just do the length of the lines, right? So that means that we can do maybe dx, because that's the length of the lines. No, that's not the length of the lines because we, oh I know that is. Because I was gonna say because we GCD stuff, but that's not true. Okay, right? dy in this case, right? And then now here, instead of doing this, we add the length of the line, right? That's so now this represents one line instead of thing, and then because n squared, we would get all the pairs of points in that place anyway. So yeah, maybe, or dx. Is it dx or dy? No, it's the length of the lines, right? So it's actually dx squared times, because length of the line, technically you have to square root it, but you can normalize it that way. So then now these represents number of lines, so then now we don't have to do this thing anymore, right? And instead, the number of pairs, well, we don't have to do that, but we don't have to do the times 2, but actually it's just plus count, right? And this is not an add. Because the length of the line should not be a set, right? It is just, it should be the count. There should be a count of the length of the line, so that so now instead this is going to be a counter. Sorry, getting a text. Okay. Okay. Because what we want then now is actually the length. We want to increment by 1 so that we can. This is so annoying, and I think this is right, but it's just error prone, so it can have issues. That's why I'm like just not happy about it. And now technically, maybe we want this instead, which is now everything is the same, right? It's just that, yeah. Is that right? What am I doing? Okay. I mean, I think this is okay. The idea is that, let me double check in my mind. The idea is that if the length is the same and they're parallel, then that means that the other lines are the same. So that means that we double count those, right? So then, yeah. Okay, so does this give me the same answers as the other ones? Hopefully. Oh no, of course it doesn't, because I am doing some crazy stuff going here. Okay, this is the number of lines, slope, the y-intercept. Slope is n squared, b could be n. Maybe this is crazy. Why is it so hard? What am I missing? Maybe the line things doesn't make sense. Hang on. Okay. I'm trying to bring up my drawing things so I can think about it or visualize it a little bit differently. I really did miss this case though. What other ways can we do? Okay, so we go, okay, we have this length, right? And we just want to parallelogram it. So the number of parallelograms, no, I mean, this should be fine. Oh, but the length might be a little bit too much. Basically, you want to subtract out all the stuff that isn't that one. Yeah. But I mean, I think the way that I want to structure it does work, just to be clear, but it may, the complexity I don't think makes sense, or I don't think it works, because then now you're like counting out the things that doesn't count or whatever, and I have to figure it out. Can I, maybe I could do another way of counting parallelograms. Give me a second, let me, I don't want, I mean, you know, I'm not trying to look at the other ones, but I want to take this one back for a second before I did the length thing. Okay, right. So this one, it fails on on the parallelogram. So how can I count parallelogram? Oh, you didn't see me because I blocked the screen. I didn't do much. I just restored the my wrong answer solution to here to take out the length thing. Maybe we could count the parallelograms outside, right? How do I count the parallelograms outside? Now let me bring the thing drawing back in. You can count the sides. You can also count the diagonal, maybe. How does that work again? You have something like this. You get 2 points. So all you have to do is try to find the inverse slope, maybe? Is it? I always forget about the thing. No, it's the thing where, okay, the midpoint intercepts. Yeah, that's right. I forgot about that one, that idea. Okay, because then now, okay, so then this is right, except for double counts parallelograms. Then now, yeah, let's see, how did it go? Well, we'll just do the same thing here. I mean, not the same thing, but here, right? So then now we want to say, how does that work again? So you get the midpoint. So I feel like I'm like in that really old show. Now it's an old show. Was it Queen's Gambit or something? Where like she looks at the ceiling, and that's basically what I'm doing. In case you're wondering, I don't have the hidden answer to my right, or if I did, I would be much faster. But okay. So what's the midpoint idea again? So you do. What do I put in it? I just put the line. I guess so, right? And then every other thing that has that thing. Yeah, right? Because it doesn't have to be. Wait, does it? I don't remember. What do I have? Something like. Okay, so the midpoint's here, and then you have, say, the midpoint's here. Does that make sense? I guess so. That looks really awkward. Is that right? I feel like I'm drunk sometimes. Okay. So basically, let's say you have to do. No, it doesn't help that I'm drawing like a maniac, something like that, right? Then now you have to, but like this has to be like thing, right? So you can't have like so why can you have something like that? Oops. Doop. Doop. Then now you have this. Does it have to be axis parallel, or what should we call it, parallel? Is the midpoint enough? Oh, I see. The reason why you need a slope is because you can't have in the same midpoint. If you have, okay, if they're in a line, then you do not have a parallelogram, is my point, right? So then now, okay, because basically you cannot have like a line that looks like this, pretend is at the midpoint, and then a line that looks like this. So you have to basically midpoint and the slope will uniquely, as long as the slope is something else, then that's fine. Okay, I think I get it. Okay. So then now what would I call it, right? So we just call, I don't know, mid. Something like that, right? Yeah. I guess I normalize the slope like this. Can I do all this? Okay, fine. But only the slope part, I think. I probably should change that into a function, but okay. And then now that we have the slope, we have the midpoint. Right, midpoint is easier. As you go to it's, and then it's I know it's technically over 2, but we'll just take out the over 2 part, right? So then now we can say mid of mx my slope increment by 1, right? Then now we do the math again. For midpoint in we don't really care about this, I think. Basically now for each midpoint we want to take everything that's not the same slope, right? So okay, so then now let's say total is equal to 0, and maybe we'll do p for parallelograms. Then now we just sum it all up, right? We have for slope in this, so total we added, okay, with Gucci. And then now here we do it again, which means for each slope we want to count all the ones that does not have the same slope. So that means it's going to be this times total minus this. And again, this is double counting, so yeah, but then now we just do p over 2. I think we should be fine, hopefully, please. I want to go to sleep today. Okay, let's see if that works. Did I forget a print statement? Yeah, if I did, I guess I will find out soon enough. It works for that one then. Oh no! What did I miss? Is it the parallelograms? Oh, I don't want to debug this. Wah, wah, wah. Okay. Is the midpoint wrong? No, midpoint should be right. What am I getting wrong though? I think the parallelogram part looks okay. Well, and that's this part as well, which it can possibly, it certainly can be. Do I double count it by 2? Actually, maybe that part's wrong. Okay, maybe it is. Because because here I guess I take it out, but do I do this wrong? This feels very weird. No, I mean I do double count it, but we still have extra ones. Why do we have extra ones? I mean, I think the ideas are right, but I right now I'm not certain whether it is the oh, no. I was gonna say maybe I handled the vertical things well, which maybe still honestly. No, yeah, this feels right. Let's see. As a slope. Oops. Is it that we're missing parallelograms, or we? I guess so, right? I have to guess. Does it go for no? Midpoint. What is this again? This is the slope. I mean, the annoying thing is just that, like, this is so hard to debug. Like, where am I? I'm looking for things that should be here that are not, which is not a easy thing to do, right? Even though the ideas may be right. Well, we're overcounting, but I think that this part should be right, so I'm guessing it's. I want to say but this part also looks kind of right, but maybe the vertical and the horizontal I don't handle correctly. I don't know. And these are the midpoints. There should be n square of them, and I guess this is a very big case. Is this right? No, it should be right. $48. Missing like 6. Did I do any of these right? Do I overcount them? I don't think I overcounted these because it's not really. Then I'm undercounting the parallelograms. The slope. Okay, let's see. So if it only has one slope, we just skip. Otherwise, let's print it out real quick. Maybe that'll help. But that means that something is missing from this list, so maybe that doesn't help. Alright, I'll be right back. I need to turn off the AC because I didn't think this was going to go on for so long. And the AC has kind of like been just wearing on me. Alright, okay. My watch is telling me to get up. What does this mean? Well, like, why is it 591? What is this again? That's the slope. Why is this so coincidental? That's the. I don't know. Does that happen a lot? I guess so. I don't know. This is just one of those silly days. Did I miss in parenthesis? This part is probably right? I mean, I'm not double. Well, maybe not. Maybe the B. I don't know if the y-intercept can be like some really small thing that makes it like error out or something. Okay, let me see if I can reduce this to a fraction, right? Or not a fraction, I mean. What is the fraction class? Because one of my current hypotheses may be that I guess this was always a little bit on the riskier side, and maybe that it gives two b's that are slightly like rounding error apart or something like that, which may give me which may double adds counting to the makes an issue to it, I guess is my point. What is the Python fraction class? Fraction. I usually don't use fractions, but maybe I should learn a little bit. Okay, fine. Right. So slope is equal to. I don't know if this is going to be fast enough though, but alright, let's see. And then B slope divided by no times dx, right? Or x1, right? Does that work as a fraction? Do I have to do anything specific? Alright, I just want it real quick. See if that gives me from fractions, import fraction. Is that a fraction? It's a fraction, I always forget. So it was a fractional thing then, huh? What did I do last? Well, I'm going to YOLO submit. Maybe it times out because fraction. The reason why I don't usually use fraction is because it's just slow. But maybe that's a premature optimization that I've been just something that I've been doing all my life, or kind of thing. Time limit exceed. I mean, that means that's an improvement, kind of, right? It's not good enough, but it, you know. Oh, it may be because we're printing too much though. Hang on, let's try again. I think this probably works, but that is a thing where we actually am printing too much. I'm surprised we didn't get what's it called? Output limit exceeded first. Well, I don't know. Maybe it's still too slow though, honestly. But okay, so it is still a little bit too slow, but at least it's more correct. So it's the fraction thing that's a little bit awkward. Because before, yeah, okay. So good news is that our math is right. Bad news is that we still have to figure out how to do this implementation thing. I mean, in this case, we don't need to calculate the GCD. Maybe that kind of adds up. Because this is n, we do n squared of them. It looks slightly faster, but maybe not by faster enough. There's some maps that we can optimize here, but I don't know if it's worth doing. I mean, this part, okay, well, we don't need it for the other one, so let's take that out and put it here, maybe. This if statement is true, right? If there's only one slope, then we don't care. But there's a similar optimization somewhere here. Well, because this is doing the length, right? Do I have to do set? Maybe I could get rid of the set operations. Let's see. Do I have to do a set? How does this work? No. We just do the count of the pairs directly, right? This is one pair. Right? Don't think that's... Oh. No, that's right, I think. Because now we're doing pairs instead of... Okay, because we're adding one on the number of pairs, so it should be pairs directly. Right? Okay. It's only a little bit faster, unfortunately. I was hoping it would be a lot more faster. Let's give a spin real quick. If not, I might just do the change the language trick because I feel like maybe that's fine. We got one more solution. Yay. Did I change the language last time? No. Okay, I could figure it out maybe. The fraction stuff is really bugging me though. But this is why I also don't incline to use fraction. Because of this exactly, really. Well, get rid of the absolute value, because if it's 0, then you don't need the absolute, right? And that's n square operation every time, I suppose. Let's see, should be another similar thing here, right? Which is that I guess, I don't know. Oh, I mean, this is terrible timing. But at least I mean, algorithmically, we got the solution. I don't want to say quickly, but we got most of the solution, the trapezoid one, pretty quickly. The wrong answer actually gave us what we needed to fix with the parallelogram, and we got that quickly. Well, maybe not. We got that eventually, but then the fraction stuff is weird. What did I do last time? I guess F is, I don't know what F is, but P is the parallelogram. We did the math slope. Oh, we do the, what's D2 again? Oh, I did do the distance thing that I was kind of trying to do, but didn't end up doing. I mean, I started on it, but then I didn't do it. But this is also crazy looking. I don't know. The parallelograms. But the idea is the same thing though, so I don't know. Maybe it's fine. I don't know how I feel about it. This form's just weird. I don't know. I don't know what to say. I mean, I think the idea is fine. The ideas are fine, but it's just that there's so many issues with. Yeah. How do I handle the fractions? What's A? Oops. I guess I just did the math, huh? And then because that's the intercept, right? Though I say B on this one, but I guess I just did the math manually, which is very complicated instead of using fraction. Yeah, I mean, this is n square, very complicated, very difficult n square, but n square. Hopefully, y'all learned something, which is that, this is a ridiculous problem. But yeah, I'm tired. Sorry, friends. But yeah, the idea is, of course, I don't know. In the beginning, I felt like we were doing well, but then it kind of got nuts. But yeah, that's what I have for this one. Let me know what you think. Thanks for watching. And yeah, let me know how you did with this one. I'll see y'all later and take care. Bye bye.